All right, good morning, everyone. Let's try that again. Good morning, everyone. Good morning. Thank you. Assume everybody has had some coffee already or something. Maybe everyone's still asleep like I am. Welcome to this session on enterprise cloud patterns. What we're going to do this morning is go through some of the enterprise cloud patterns that maybe some of you have seen before, but we'll do a bit of review on cloud native and other things as we go through this. My name is Pratik Patel. I'm a Java champion, and I also help organize the Atlanta Java User Group and one of the best Java conferences in the world, DevNexus, which is run by the Atlanta community. So if you ever get a chance, please come and visit us in the ATL, or Hotlanta, as we like to call it. And I work at Azul Systems, and we make what I think is the best JVM in the galaxy. We also have an open source build of the OpenJDK, and we have our high-performance Azul Platform Prime, it's a mouthful, high-performance Java virtual machine. With that high-performance virtual machine, you can get 20% performance gains out of the box. Of course, no code changes because it's a TCK-approved JVM, and more stability, better throughput, and, of course, infrastructure savings. But we're not here for infrastructure savings, right? And if you want to enter into and get one of these T-shirts, you can go to this URL and get JDK T-shirts. Before we get started, how many people are using JDK 17 in production? Wow, 2 people. Okay, it's maybe time to upgrade your JDK. Anyways, also check out fujay.io. This is a community website where you can write your articles and see articles that are written by other people. It's a great website. All right, so let's get into our presentation. So for a few minutes, I want to talk about the philosophy of building for the cloud, and then we'll do a very quick review of cloud native, because this is a little bit of a short session. It's like 45 minutes. So we don't have too much time to talk about cloud native, but what we'll spend most of our time on is talking about different types of enterprise cloud patterns. Okay? So I'm sure everybody here has built something for the cloud, and maybe you're building something right now, or you're migrating something to the cloud. Most of the patterns we'll see today are around migrating monoliths to the cloud, and some of the kind of philosophy behind it we'll talk about for a few minutes. Right? I think the biggest thing for me, at least, when I was working on moving stuff from a monolith to the cloud, was this idea of being elastic and having scalable types of solutions for the cloud. When we think of a monolith, it's not something that's elastic. Right? It's basically you spec out a server or a set of servers, and that's what you run on. If you have to add servers, it's a big process to go and add stuff, and you have to figure out how to scale your monolith and other things like that. But when I think of the cloud, I think of things which are elastic. And I think this is key when we're building stuff for the cloud, is that you have to design for elasticity up front. Right? So this is something I think that it sounds simple in practice or when you say it, but when you actually do it, it actually can be very difficult. As a software engineer, what's the one thing or the biggest mistake you can make? Premature optimization or a big upfront design. So what we do today is we try not to do too much of that. We try to not do too much upfront design. We want to be agile and we want to be flexible as we build out our solutions. But when we're building for the cloud, we do have to take a bit of time to understand what we're building for, and we have to do some upfront design, right? So this is kind of antithetical to what we typically think of when we're building solutions, whether it's for monoliths or for clouds and stuff like that. So you have to think of this up front. And when we think of elasticity, we have to think of horizontal scaling, right? When we're building a monolith, we typically think of vertical scaling, which is let's add more CPU, let's add more memory, right? Those kinds of resources, because we're doing vertical scaling. But when we're building for the cloud, we have to really think about horizontal scaling, right? And more distributed processing and distributed computing. And one of the key things around this is that your entire architecture has to be elastic when you build for the cloud, right? And again, what elastic means is something that's flexible and that you can scale horizontally by adding servers, by adding memory, by adding storage, by adding networking, all those types of different things. So these are the three major things when I think of building for the cloud. We have to think about compute power, of course, network, storage, and other things like that. Today, when we typically build things for the cloud, one of the other things that should be on this slide is how can our database scale? One of the things that we don't think about as developers a lot is how can we scale our database in an elastic way? But that doesn't really happen today because current database technology doesn't really allow us to do that. Yes, there are ways to do it, but it's not quite there yet, right? So that's something else that we have to consider. And kind of everything that couches this is, right, why do we need to think like this? And why do we need to feel or think in a way that's elastic? So, of course, for the cloud, everything is around cost, right? How much can we build? How much do we have to pay? Are we paying too much? Right? How do we right-size things? And then, of course, we have adaptability, agility, security, of course, and then time to market. How quickly can we get solutions out? Okay? So these are kind of the key tenets when I think about building for the cloud. So I don't want to spend too much time on microservices. How many people are building microservices out of curiosity? Okay, so 90% of the room. But are you really building microservices? I'm just joking. So we shall see, right? So I'm just going to run through these slides very quickly because we have a little bit of a short time here, and I want to get to the enterprise cloud patterns themselves, right? So when we think of cloud native, we think of containerization, dynamic orchestration, which means that you can go and build things and scale things on demand, and then, of course, microservices oriented. Things are packaged in a container that allows you to do reproducibility, transparency, and resource isolation, among other things. And if you live in the Kubernetes world, containers are actively scheduled and managed to optimize resource utilization. Okay. So another question, out of curiosity, how many people do Kubernetes dynamic scaling in the cloud? Okay, it's interesting. Does that work for you? So does that work for you? Just out of curiosity, when you raised your hand, how difficult was that process when you said, okay, we need to scale up and scale down? Does it happen automatically, or do you have to push a button? Out of curiosity, good. Yeah, sure.
Yeah, the scalability itself is not the problem. The software building on it,
Okay.
it scales.
Right, so the gentleman in the front actually has a very good point. It's not the actual scaling part which is the problem. It's building your software so that it scales, right? So again, it's kind of couched in this whole idea of elasticity and how can you build something, you have all the tools to do it, but how can you build something that can scale without you having to do stuff, right? Code or do configuration and other things like that. So thank you for your comment. All right, so applications are segmented into microservices, blah, blah, blah. Everyone knows this, so I'm not going to spend too much time on this. Everyone is familiar, at least, with the concept of microservices and adaptability and scalability and things like that. Of course, when you're building in smaller chunks, it's easier to go and make changes and other things like that. Speeds up development, makes it easier to adapt, and make changes to new requirements or security patches and things like that. You can scale more efficiently. One thing I think that a lot of people don't understand around building stuff for the cloud is this whole concept of stateless, right? Because if you're building a Spring Boot application, for example, you have state inside of your application and you do something like sticky sessions and things like that, right? But when you're building for the cloud, how do you handle state? So we'll talk a little bit more about this later in terms of how do you do distributed state handling across a cluster, whether you're running Kube or something else. All right? And the other thing that I like to think about is, as a software developer, especially if you're building something with Spring Boot or Quarkus or Vertex or whatever framework you like, we think of complexity down at the code level, or essentially at the modular level down here. But when we're building for the cloud, we have to keep in mind that the complexity that we're doing is no longer down here, especially if you're building microservices, right? You're building small little chunks. So the complexity that we're building is now up here. Interdependencies are up at the top level, not down at the code level. So it's actually a different type of challenge that we have to face. And we'll talk a bit more about that when we look at the Death Star anti-pattern around building microservices. Okay. The other thing is that it's harder to monitor and manage your system in production because you no longer have a single process or a set of processes where you can go take a thread dump or look at the garbage collection or other things like that. So you have to have more monitoring and you have to have observability. One thing that I like to do when I build stuff and I need observability across a number of different layers or across a critical path is using something like an open source tool like Sensu to get that observability across the entire system. So you may have heard of that tool before. It's an open source tool. Right? Okay. So now we've done the review of enterprise cloud patterns. We've kind of set the foundation that things need to be elastic. We need to build in a cloud native style. So let's talk about some of the enterprise cloud patterns. We don't have time to cover all of them, unfortunately. And we'll talk a little bit about how Java fits into this picture. Because how many people are not Java developers in this room? Okay, so what do you folks code in if it's not Java? Node.js. Okay, next person, what do you code in? Go, okay, right. So one of the other things around cloud native is that folks believe, or developers think, that you can't build cloud native applications in Java because it's not fast enough or it doesn't start up fast enough and it's a very heavyweight process. But in my opinion, and I'm a little bit biased, is that you can build applications in Java for the cloud. Because Java processes are actually very lightweight, and of course, everybody else who's in this room will agree with me that we have this amazing constellation of libraries and tools and IDEs and other things like that to help you be successful and to build something fast and build it right and build it so that it's maintainable and et cetera, right? So I don't need to tell most of the people here. So has anyone seen this TV show, by the way? This is, what's that? Right. So this was a great TV show. Unfortunately, when it was on, I was at a startup, and it was painful to watch it because that was my life on some days. Like you get that consultant who charges $10,000 a day, and they don't really do anything, but that's a different story. All right. Anyways, one other thing that I want to mention is that as we're going through these patterns, you will probably recognize a lot of them because if you're building for the cloud, you probably kind of see some of the things that are going on here, but especially as a developer, we have a lot of low-level patterns, right? We can talk about the Gang of Four book, which has the adapter and the facade and all those different types of patterns. When we talk about cloud patterns, right, we're talking about up here at more of the systems level than down here. And the patterns are pretty much the same, but again, the granularity at which we think about applying these patterns is different. Right? So we're no longer applying them down at the code level or at the library or modular level. Okay? So these are the four broad categories, and we're only going to cover some of the ones in the first one. There's design and implementation patterns, which we're going to talk about today, performance and scalability, data management, availability, and resiliency. So this is actually the first in a series of 4 different presentations. So if you follow me on Twitter, when the next one comes out, which is going to be on data management, you can go watch that and hopefully get some usefulness out of that too. All right, so we're going to only cover the ones that Java devs will find most useful for migrating to the cloud in this specific sessions. But again, there's a series of 4 that I'm working on. Hopefully will be out soon. All right, so the first pattern I want to talk about is the ambassador pattern. Right? How many people have heard of this before? Out of curiosity. Okay, good. Nobody's heard of it, so you're in the right place. All right, so let's talk about this for a few minutes. And the basic premise of this one is for doing legacy app transitioning. That means you have some kind of old application that you maybe don't want to touch, or maybe you're working on refactoring, and you need some time to do that. But in the meanwhile, you want to move it to the cloud, and you want to have it capable of cloud-native types of features. Okay? So if you look at this very badly drawn diagram, this is essentially what this pattern does. You have a client or some kind of service, right? It could be a front end or it could be a server-to-server type of call. And you have a legacy application that you want to give some cloud-native features. What are those cloud-native features? You want monitoring around this. Right? Because remember, we talked about observability across different cloud types of applications. You want the ability to have retries around it. You maybe need a protocol adapter, right? So this could be an old application that's running SOAP, for example. Anybody still writing or running SOAP apps, out of curiosity? Okay, so a few unlucky people doing SOAP applications. So you have this old legacy application, and you need to make it cloud native in some way, but you don't want to touch it. You need time to refactor it, right? Or you need time to rebuild it or whatever. So what we do is we create essentially something that looks like a proxy that if you're using SOAP, or maybe it's a terminal scraper, TN3270, whatever terminal scraper type of app, and you want to put it into your cloud architecture, but it's not ready for the cloud. So what you do is you wrap it around this ambassador pattern, okay? And it's mostly around end clients. You can make B2B. The next one we'll talk about is more around service-to-service type of calls, but this pattern is more meant for end clients, all right? And it can be relatively simple, right? It more or less is a proxy. We'll look at some code in a minute to give you an idea of what it looks like. And again, the idea is that you give this legacy application some cloud-native features. Resiliency, we talked about retries a second ago, et cetera, right? And typically, the proxy is a separate process, and if you're familiar with the Kubernetes world, you can actually implement this as a sidecar in Kubernetes, okay? You don't have to, but you can if you want, and you don't have to implement this in Java, of course. You can write it in Go, but this is a Java conference, so we're going to talk about Java here. And you want things like monitoring and retries and other things that you expect from a real cloud-native application, okay? So if we talk about some Java-specific notes, if you're in the Spring world, you can use things like health check, and of course, you can use the Spring REST template, or in the newer versions of Spring, it's now called the web client. If you live in the microservices world, there's a micro-profile REST client that you can use, and then you have micro-profile metrics and health checks that you can wrap into this proxy to give you those cloud-native features, right? And if we look at some code, I'm not going to go into too much detail on this, but if you're familiar, this is a Spring example here, right? So we have response entity. This is our entry point here. And this is our underlying service that we're calling here. We set some headers, and then we go and say, go and execute this REST template to go and get that thing. But again, this doesn't have to, in this case, it's just kind of a RESTful JSON call. But again, if you're building something with SOAP, or if your legacy application is built with SOAP, or if it's built with something else, you can do a protocol adaptation here so that you can speak to it, right? Is anyone still using RMI or Corba out of curiosity? Okay, good. Just wanted to check. It's like 1999 call. They want their network protocol back. So, anyways. All right, so let's move on to the next one. And this is a variation of what we just talked about, right? So this is the anti-corruption pattern. And again, it's also for legacy app transitioning, right? So the theme of this presentation in general is around legacy apps, but we'll also talk a bit about microservices in the next one. So, you have a number of different apps in your cloud-native architecture, right? You may have microservices, maybe you're using cloud functions, maybe you have event streaming with Kafka, right? How many people are using Kafka out of curiosity? Okay, that's less than I thought. I thought everyone used Kafka now, right? It's what everyone talks about. Actually, how many people are building cloud functions also? Okay, that's a very small number of people. Are you building them with Java or Go or Node or? Okay, you're using Python. Yeah. Okay, and somebody else raised their hand. I think you did. Yeah. What do you use for? What? You use Node. Okay. And there was one other person, just out of curiosity, over here. Yeah. Well, what do you use to build your cloud functions? Okay. Interesting. I'm not going to go into a diatribe on Node right now. We'll do that later. So, it is a Java conference after all, right? So. The basic premise of the anti-corruption pattern is service-to-service calls, right? The previous one is more meant for end clients, but you'll see that's very similar to what we talked about previously. So we have our cloud-native apps that we've already built out here, and we have this anti-corruption layer, which again calls into some kind of legacy application, okay? Consumers, other services, and it's a little bit more sophisticated than a straight proxy that we do with an ambassador pattern, right? We have other things that we want to roll into this. But as you probably guessed by now, this is a facade and adapter pattern, like the previous one that we talked about. But the basic premise here is that we want to firewall our legacy applications and have some protection for that underlying thing so that we don't stress it out too much, make it crash, other things like that. And again, useful for migrating legacy apps to the cloud, right? So we have protocol adaptation that we can do in here. And this is especially useful for things that we don't want to change or can't change, right? It could be something that's SOAP. It could be something, could be some kind of terminal scraping application. And the basic premise around this is that we want to compartmentalize this application so that we protect the application and we protect the rest of our cloud native architecture for the overall app that we're building. Okay, so if we think of some Java-specific notes around this, nothing too crazy here. We can use Spring REST template, and we proxy code, of course, down to our legacy app. And if you're in the micro-profile world, you also have that, different types of things. All right, so let's move on to something a little bit more interesting, the gateway aggregation pattern, right? So we'll talk about the Death Star anti-pattern as we discuss this specific one. All right, so I want to take a little bit of a step back, right? So when we build applications today in a monolith style, we think of integrating code down, we think of integrating features down at the code level. And when we're building microservices, we're doing integration or dependencies up here, more at the kind of modular or systems level. And this is very important when we think of an overall architecture, right? So the gateway aggregation pattern looks something like this. Right? So we have a service or we have a client, and then we have some kind of aggregation gateway, and we have service A, B, and C, as you can see here. And what the gateway aggregator does, it basically goes and weaves these three things together in a specific way, and it allows the service or client to make one call rather than, in this case, 3 calls. Right? Again, so when we're building microservices, we're building things which are this small. So we have to call multiple different microservices to get stuff done. Right? But this can be a problem because if our service or client is calling down to all 3 services directly, we're creating multiple levels of dependency from the client down to the service. Okay? And you might be thinking, well, that's not a big deal. Right? So if you have, like, say you're building like an Amazon or some kind of online shopping platform, right? What do? You go, when the user comes to your website, you go get the user's profile, you may get their saved shopping cart, you may get some featured items and blah, 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 right? So you make multiple calls to go get those things, which is fine. But what this specific pattern does is it helps avoid what's known as the Death Star anti-pattern. So some of you may have seen this specific picture before, right? So if you look at Amazon and all their interdependent services, this is different services calling each other. But I think Netflix was the first one that actually came out with a nice article discussing how the thousands of different microservices there were at Netflix, how there were interdependencies between them, right? So what you end up with is this big ball of mud or this interdependencies between different things. So when you're building microservices style applications, you have all these little services, and they sometimes need to call each other, or there's a sequence of services that you need to call if it's a client, and you end up with something like this. So you end up with this constellation of dependencies between different services. And why is this bad? Right? The answer is actually not that hard. If you look at the picture on the right, if one of these services goes down or you need to patch one of these services, what is the network of different things that are dependent on it that also then need to be shut down or need to be put on pause or whatever? So you want to try to avoid having too many dependencies between your microservices, and one way to do that is to apply this gateway aggregation pattern. Right? So if we go back to this diagram, right? So what we do here is we have these 3 services which will be called frequently by some other service or by an end client, web browser, mobile app, whatever. And we want to make sure that we provide these services to whoever is the consumer, but we don't necessarily want to create that hard dependency between them. Because, again, we want to try to avoid this Dead Star anti-pattern, because what it does is, once you hit this level, you've created an architecture which is inflexible and difficult to manage, difficult to upgrade, et cetera, et cetera. It's the opposite of what we're trying to do with microservices. We want flexibility. We want to be able to adapt things. We want to be able to patch things. We want to be able to release things very frequently. So, yes, sir.
Is that ESB is coming back, or what is that? It looks like ESB.
Okay, so you have a very good comment. The comment was, this looks like an ESB, or what's known as an enterprise service bus, right? So for those developers who've been building stuff for a while, you know what an ESB is. And your comment is actually very good. In a lot of ways, when we think of this gateway aggregation pattern, we are kind of building an ESB, right? So I'm going to show a little bit of a code sample, which is kind of low level, on how you can build this gateway aggregation pattern. But one tool I like to build a gateway aggregation pattern out of is Apache Camel, right? So you mentioned ESBs, and if you're familiar with building enterprise service buses, what's one of the main tools that you can use to build it? Apache Camel. It has a great set of different tools or different features inside of it that allow you to weave different things together and build an enterprise service bus. So yes, you're absolutely right. It does look like an ESB, and it kind of is an ESB. So, okay. All right, so as you can guess, we aggregate calls to services. The client interacts with the gateway rather than directly, which we already talked about. But one of the things that we have to consider when we build something in a gateway aggregation pattern is what happens if there's a failure in one of the downstream services, right? So if you've been building code for a long time, you understand that nothing in software development comes free. And especially when we think of software architecture, everything is a trade-off. So in this case, we're trading off some simplicity to the front end for some extra complexity on the back end. And we have to be aware of that extra complexity that we're adding. And in general, as software developers, we like to make things as complex as possible, right? So it's always a challenge to not make things more complex. It's always a challenge to not over-engineer something. But sometimes we have to introduce this not incidental, but specific type of complexity because we're trying to solve a problem. We're trying to avoid a larger problem. So anyways. All right, so for something like this, you can use async REST template. I also mentioned Apache Camel, which is a great way to build something like this, to do a great gateway aggregation pattern. And I'll go on a little bit of a side note about GraphQL in this case. How many folks are using GraphQL out of curiosity? Okay, so not that many, which kind of makes sense because in the Java world, we don't really think about GraphQL. We think more about RESTful services and making discrete calls to endpoints in a REST-style fashion. So when I think of GraphQL, in my mind, it is actually a little bit of a gateway aggregator. Because if you're not, everyone's probably heard of GraphQL, at least in this room, right? Is anyone not familiar with GraphQL? Out of curiosity? Okay, good. So everyone's at least heard of it. So when we build out something with GraphQL, and there's some good libraries, for example, for Spring that allow you to build out a GraphQL type of solution. But when we make a RESTful call, what do? We say /users, /user profile, /shopping cart. So we get like a discrete, very compartmentalized type of data back from the server when we make that kind of call, right? But when we make a GraphQL call, it's more about go get the user and the user's profile and the user's saved shopping cart, for example, right? So what we're doing is we're combining different things, and we have to code that GraphQL endpoint that we're building to allow us to go and get these disparate different types of data, or maybe related data. It doesn't matter, right? So in a lot of ways, GraphQL is kind of a gateway aggregator. So if you're not familiar with how you can build stuff, there's a couple of good libraries, for example, in the Spring universe, and then in the MicroProfile or Quarkus universe, you can use small GraphQL to do the same kind of thing. But what we do when we build out these GraphQL endpoints is we say, I want this data, and I want this data, and I want this data, and I want it all combined into one, so the client only has to make one call to get exactly what it needs. Whereas when we build in a RESTful style, what we do is we say, I need this, so I'm going to call and get this, and I need this, I'm going to call and get this, I need this, blah, blah, blah. Right? So you get the idea. We make multiple calls in a RESTful style, whereas the idea with GraphQL is that we can make one call and get exactly what we need for whatever the user wants at that point in time. Okay? So in a lot of ways, GraphQL is a gateway aggregator. All right, so let's look at a little bit of code. This is Spring again. Right? We say a get mapping, and then we have three completable futures here that go and call something on the end. I've just truncated this at the end. So we're calling three different things. And if you haven't used a completable future, we say completable future.allof future 1, 2, 3. Go and run that. Once we get all the results, we combine them, and then we send back a response. Okay, so you can build this by hand if you want to, or you can use something like Apache Camel or some other tools to do that. Okay? All right, so let's move on to the next pattern. This one is called Backend for Frontend, or BFF. And what this allows you to do is, this is another kind of facade and adapter pattern, which gives you the ability to have some flexibility and performance for the different types of front ends that you have. Right? So you may have a native mobile application, or a web mobile, or a desktop web. And what we do in this case is we build a specific adapter, or a BFF, for each one of these, because you want to send a specific type of data. And of course, you could have a legacy application underneath it, or a microservice, or whatever. Okay? And what the BFF does is it's basically almost like a protocol adapter. Right? So for a native mobile application, you may want to send some binary data, or if someone is coming and requesting something from a web mobile, right, from their phone, maybe what you want to do is, instead of sending a large image, you want to send a mobile optimized image, right? Or maybe you want to send a smaller data set. Whereas if they're coming from the desktop web, they'll probably be on Wi-Fi or some kind of fast network type of resource, so you can send a large image, you can send 100 rows of data or whatever. Right? So the idea here is, again, around protocol adaptation, but I think the key thing here is that this is something that you build so that you keep your front-end developers happy. How many people build for the front end out of curiosity? Okay, so we have a couple folks here, or a few folks here, that build for the front end. And a lot of times, teams are segmented into people who do back-end stuff and people who do front-end stuff. Sometimes teams are combined, where a developer does both the front-end and the back-end, right? But that's usually not very typical nowadays, because the front-end, I know this is being recorded, so I'll choose my words carefully. The front end is very complex nowadays, right? It's not like the good old days where you rip out some HTML and you're done. And now you have to go and do an npm install and let it install the universe before you can build something. So we used to make the joke in the Java universe that you start up Maven and it goes and downloads the universe, and now the front end people are making that same mistake. But anyways, I won't say any more about that. You get the idea, right? So the idea here is that what you do is you provide something kind of almost at a team level, that instead of making your front end people design and build for what you have on the back end, you provide them with exactly what they need. Instead of them having to adapt to what you do, you go and adapt to what they need. Okay? And I think this is very important in a lot of ways, because this gives you the ability to be very flexible on the back end then. Right? If you have a microservice or legacy apps or whatever, right? You have a big number of different services that your front end will call. If you're able to go and change what you have on the back end, and when you make those changes, all you have to do is apply some small changes to this intermediate layer in the middle, it gives both you as a back-end developer flexibility, and it gives the front-end developer a lot of flexibility as well, because now they don't have to go and change every time you make a change. As a server-side developer, you go and build something in the middle that goes and adapts to whatever changes you're making. And of course, you can swap out different microservices, or you can migrate to different microservices as you need. Okay? So, as you can imagine, this is also possibly a gateway aggregation pattern, right? So you can also aggregate things if you need to, right? Rather than just calling in individual services from this middle layer. All right. And of course, I spoke about this earlier. As software developers, we have to be very careful not to over-engineer things and also to do too much premature optimization, right? So we like to build things and we like to make things complex and cool and sexy, but we have to be careful not to do that all the time, okay? All right, so we create a separate backend service for each front end. Data can be shaped and sized for specific needs, as we talked about, right? Mobile web, desktop web, native client, maybe it's a service that's calling it, who knows, right? But typically, it's some kind of front end, right? And out of this, we can also get improved performance because we can shape the data and size the data appropriately for the specific client that's calling it. We have to be mindful of code duplication, right? Because we have maybe 2 or 3 or 4 different BFFs. So are we sharing the code between those BFFs, or are we rewriting the code? Are we copying and pasting? So we have to be careful about that. We already talked about the structure of the team and how that kind of plays into this. Okay? And we already spoke about GraphQL versus REST. For me personally, I like using GraphQL sometimes, but again, I try not to create too many dependencies between different underlying services as much as possible, but sometimes you have to. So I do like using GraphQL occasionally. It can be a little bit difficult to do that in Java because we have good libraries for building GraphQL solutions in Java, but we don't have great libraries for building them. It can be a little bit tedious to build stuff like that, and it can also be, in my opinion, a little bit brittle with the current libraries which are out there for building GraphQL in Java. Okay? All right. So we're not going to look at code in this specific one because we kind of looked at things again already. You can build these BFFs using something like an async REST template in Spring or the REST client builder in MicroProfile. All right, so let's move on to the next one. This is the gateway routing pattern. And everyone is familiar with this, believe it or not, right? It's already used quite a bit. And sometimes I like to say it's a misuse because people tend to rely on this gateway routing pattern quite a bit for how they build out their infrastructure and how they build out their services. Okay, so let's see what this looks like in a second. API gateways are a kind of gateway router, right? So everyone uses an API gateway. If you're building on Amazon or Azure or GCP or whatever, you're familiar with the API gateway, right? Everyone uses them. It was a big thing several years ago, and it's kind of part of our overall architecture nowadays. Right? The basic idea behind a gateway router is you have something in the middle, right? So you have either services or clients, and then you have something in the middle which says, for users, go over here, for a profile or for a cart, go over here, et cetera, right? So it's something that sits in the middle and gives you a singular endpoint that your clients can call. And you can change the stuff behind the scenes if you want by going and reconfiguring your API gateway or your gateway router. All right, so we use a gateway as for downstream services. Gateway routes to the appropriate service, and there's the possibility of doing some abstraction here, depending on what kind of gateway routing engine you're using. Okay, and one of the common things around, for example, API gateways and gateway routers is people mix in authentication and authorization directly into the gateway router. Right? So you probably, if you're building again on AWS or on GCP or on Azure, you're familiar with what this does. So it allows you to do things like authentication, allows you to do things like flow control, rate limiting, et cetera, et cetera. Right? And part of the reason why this is a useful pattern is it helps minimize change to clients. You can go and change something in the back end, and you just have to reconfigure your gateway router to say, well, now the new backend for profile is over here, right? Or you can do migrations and other things like that. And one of the nice things about this is that it also helps to reduce coupling directly to services. So we talked about the Death Star pattern previously, right? And having those intermix or this mesh of different things that call each other. And we want to try to avoid all those high-level dependencies as much as possible. So this is one way that we can do that, okay? And as you guessed, this is yet another example of a facade pattern. So one of the things that we have to think about, though, when we use the API gateway or a gateway router pattern is that we have some trade-offs that we have to think about, right? Are we introducing extra latency into our system? Have we created a bottleneck around this? Is it also a single point of failure? Okay? Like I said before, when we build things in software, nothing comes for free. Everything is a set of trade-offs. So when you're building something and when I'm building something, I like to think about, okay, so I'm going to add this thing in, but what's the trade-off that I have? Because I at least want to know that. I want to articulate that to my team so that they understand that these are the trade-offs we're making when we do something like this. Okay? And as I mentioned before, typically people don't write these gateway routers or these API gateways. You just use whatever your cloud provider does. Right? And if you're not happy with what your cloud provider provides in terms of the features for that, you can also use some other off-the-shelf API routing tool. So my friend Victor Gamov is here. He works for a company called Kong, and they make basically an API router and other things that help you build out an architecture that uses this style of architecture. All right. So we're at the end here. We have plenty of time for questions, so let's hear some questions or some comments. Yes, please. Yes, you.
Probably more of a comment.
Yeah, go ahead.
With your point for Graphql backend and frontend, I'd say one positive, if you subscribe to clients owning their interfaces, it means that your front-end team can define or contribute towards the GraphQL schema, and then your back-end team can implement it, so you kind of get loose coupling, but also the team works together.
Yeah, so actually very good comment here. He was talking about, the comment was around GraphQL and that the front-end team and the back-end team can work together for the specification around the GraphQL. And what was the second part of it? Just so I can repeat it for the audience.
Yeah, so the front-end team can contribute and, say, make a pull request against the schema itself, and then the back-end team can review that and actually implement the internals.
Right. So the comment was that the front-end team can make a request for what the schema looks like that they're actually getting, and then the back-end team can implement it, and they can kind of talk about it and build something that works really well. Right?
Yeah, so you've got loosely coupled teams.
Right. And so you have loosely coupled teams. Exactly. So that's a great comment. Right. Anybody else? Questions, comments? Yes.
Yeah, you talked about the gateway aggregator pattern, which
Yes.
I think works perfectly with idempotent GET requests. But what about when the downstream calls are starting to change stuff? Does that still fit the same pattern? In your opinion, is that a different pattern?
Okay. So the question or the comment was for the gateway aggregation pattern, what happens when the downstream services change, right? And what's a specific question around it, just so I'm clear on it?
Yeah, so maybe if you do 3 downstream calls and the second one starts changing stuff, but it fails,
Right.
the first one may provide different results and stuff like that, so that it's not idempotent anymore.
Right, okay. So the comment was is if you have multiple downstream services that you're weaving together and one of them changes, how do you handle that and what do you do around that, right? And that's a really good point. And what I like to think about when you're aggregating multiple different services into one is you are creating a dependency between them. So the trade-off is that you create an overall simpler architecture at the top level, but you're adding complexity down at the bottom. And how do you handle that? So one of the things that when I work with customers around this is one of the things I like to try to tell them is that typically when we're aggregating different downstream services, it needs to be done at the team level and not across teams. Because teams, like a team will create maybe 5 or 10 or whatever, some number of services. And if you try to aggregate services between different teams that are building things, it makes things more complex because now you have to have the teams communicate with each other and things. So I try to steer them in the direction where when we do this aggregation, it's done within the team itself or the services or endpoints or whatever that the team is creating, because it just makes it easier when things change or when things break or patches need to be done, because then you don't have that inter-team communication which can slow things down. So unfortunately, there's not a great answer for that, right? But if you think of like the structure of your company or your team or whatever, and you try to keep it at the team level, it makes that much easier, in my opinion. So, okay, yes.
Yeah, and this is regarding the BFF stuff. Right?
Yep.
So in Angular, they are having the TypeScript focus and the backend thing, and React also they have some microservices to handle the behind.
React has what?
Component and services.
Yeah, that's right.
The purpose is to handle the backend stuff. So the BFF stuff, how it gives some, what do you call it, how it will be effective, because they already have something on the front end to handle the backend. So why we need to have other ways?
Okay, so very good comment, which is if you're using a modern front-end framework like React, they have tools on the front end that allow you to do some of the things that you would do in a BFF type of pattern, right? That's a very good point. So when I think of something like React or Angular or Vue.js and the level of sophistication that they can get on the front end, and do they really need, well, it's not the right picture. Let me go forward or backwards. Right? Or do they really need something like this? And the short answer is, I think usually they do. Because yes, you can do all that stuff on the front end, but when I think of, like, if I'm a quote unquote full stack developer and I'm building the front end and the back end, what I prefer to do is I prefer to have more of the complexity on the back end rather than the front end. Okay, but I might be a little bit biased because I'm mostly a server-side developer, right? But I feel like it's easier for me to make a change on the back end than to ship a new version of the client out to the front end. Right? So when I think about something like what you specifically said, which is, yeah, I can do a lot of this on the front end using React or Vue or Angular or whatever, but I like to think in terms of velocity of the overall team. Right? How fast can we get something out? When we need to make changes, how fast can we get those changes? And yes, there of course CI and CD pipelines for front end as well as back end, but to me at least it feels it's much easier to make changes on the back end rather than have to push out new code to the front end for different clients, or even if it's just desktop web or mobile web. So, but yeah, absolutely, you can do some of these in the front end rather than the back end. But when I think about this, I also think about the shape of the data and the size of the data. And also, I can do aggregation here, right? Whether it's with GraphQL or whether it's some other way that I can aggregate downstream services to reduce the amount of dependencies from the front end to the back end. So, okay. Is there a question? Yes, please.
Today there is a lot of standard, let's say, in order to make into communication between services. Do you see in the future this kind of GraphQL schemas in the standards, like open banking or something like that?
Okay, so let me make sure I understood your comment properly. You're saying that, do you think there'll be some standardization across GraphQL or other types of, what's that?
Aggregation.
Or aggregation, yeah. That's a really good question. I don't know if I have an answer for that. Because one thing that we're not good at as software developers is agreeing on things. Right? So when we think about standardizations, in the Java universe, we have like a JVM and we have an API, standard API and blah, blah, blah. But if we look even within the Java universe or front end or Python or anything like that, like there are multiple libraries for doing multiple things. And I don't feel like standardization is something, even within an industry, that happens very easily, right? Whether you're in banking or, whatever. So the short answer is, I don't know. Okay, yes?
So, word of commentary on the Death Star pattern. I think a year or 2 years ago, Uber released a very nice article on how they approached it. And what they do is they separate into domains, and they named it domain gateway.
Yes.
So yeah, this is so any comment on that? Because I saw this in one article. I think it didn't get enough traction. So I'm
Yeah.
curious, what do you think?
So the gentleman in front has actually a very good comment. Uber released an article, Uber Engineering released an article about a year ago, and they have something called, remind me, domain gateways, right? And it's actually a really good article to read, especially if you're building like lots of different microservices. And again, the comment was, Uber Engineering put out an article about a year ago on domain gateways, which is kind of similar to API gateway, but more around features and kind of business. It ties in like your business different types of things, right?
It gives like vertical separation of the whole Death Star, right? So,
Yeah.
You cannot like call any service directly, but every team or every domain or people working on that are responsible for maintaining their own gateway. I think it will pick up more traction.
Yeah. So.
Another way to approach.
Yeah, so for the online audience, I just want to repeat some of what you said, which is the domain gateway allows you to do vertical slicing of basically all your different microservices, and there's not necessarily interaction between those vertical slices of your domain. It helps to avoid the Death Star pattern. So excellent comment. Thank you. Okay. Looks like we're out of time. Thank you, everybody, for coming. I hope you enjoyed the session.